Back when we introduced the iterative development process, we said that the designing of an algorithm began with the visualization of exactly what that algorithm needed to accomplish. In this lesson, you'll learn how to create flowcharts to help you as you develop algorithms. You'll also learn about sequencing, which is the simplest of the 3 logic structures we'll study. Last unit, we learned about what algorithms are, how they help us to create a blueprint, or you could say a map, for solving a problem. And it's a set of step-by-step instructions that have to be followed. So this lesson, we will build on that and take it a little bit further and talk about how we format algorithms, how we show them. And there are 3 core structures for algorithms that we will talk about: sequencing, selection, and iteration. These can be used independently, or they can be combined in all kinds of different ways, in all kinds of different patterns. And a good problem solver is going to learn to recognize these 3 features and to easily use them to construct simple, effective, and elegant solutions to the problems that they are trying to solve. And with a lot of practice throughout this course, you're going to develop a trained eye so that you can quickly recognize each of the common patterns, even within your everyday actions. In fact, you will more than likely discover that you already know these. You already use them without even noticing. Over the next few units, we're going to see that nearly all programming languages are designed to make it easy for programmers to write code that uses sequencing, selection, and iteration. However, in this lesson, we are going to focus on sequencing. So we can see here that sequencing is a very simple, probably the most simple out of all the patterns that we see in algorithms. Sequencing follows a sequence, as you would expect. Each step of an algorithm is going to follow the previous step. There's no jumping around. It is just step by step, one after the other, in the order that they occur. The steps of an algorithm are arranged in whatever order they should be completed. Each instruction is executed one at a time in the exact order that the algorithm specifies. Let's look at an example of an algorithm that uses sequencing that should hopefully be very familiar to you, and that is how you get dressed. So on the screen, you can see that we've got a list of instructions, 1 through 4, that need to be completed in a certain order. So step 1, you put on pants. Step 2, put on the left shoe. Step 3, put on the right shoe. And then step 4, put on a shirt. You can see that the list of instructions is set up to be completed in that particular order. And anytime you're using sequencing, you have to explicitly state in which order you want the computer to follow the instructions. The computer is going to follow the order of instructions that we call for. And this is how we decided to do it in this particular moment. All right, another example. Again, one that you should be very familiar with: brushing your teeth. So here we have, again, 2 different sets of instructions, and they are clearly specified in a particular order. So over on the left-hand side, we can see that we have instruction number 1, toothpaste on toothbrush, followed by instruction number 2, use toothbrush to clean teeth, and finally, we would complete instruction 3, rinse toothbrush. We can see that this is absolutely going to result in having clean teeth. Now, let's take a look at scenario 2 and see how this is different. See how sequencing is not used effectively in this scenario. So here we have step number 1, and step number 1 says use toothbrush to clean teeth. But we never actually put toothpaste on the toothbrush. We don't do that until step 2. And then after step 2, we don't repeat the instruction to use that toothpaste on the toothbrush to clean our teeth. We simply rinse. And so we end up with a giant glob of toothpaste in the sink and not really clean teeth, which wasn't our objective. So you can see that these are the same 3 instructions, but in this case, the sequence that we call for in our algorithm is extremely important. In a sequencing structure, every action or event leads directly to the next action or event in the list. And that's why we have the term sequencing, because things happen in a sequence. And the list can be long, short, any length, but nothing can be skipped. And we're going to look at sequencing examples in Scratch in the next lesson. But before that, we want to talk a little bit more about how we show sequencing and how we might visualize it as we're trying to develop a program, an algorithm. And a tool that we can use to structure algorithms, including those that include sequencing, would be a flowchart. A lot of times we want to visualize all of the pieces of the puzzle, all of the components and the relationship of one component to another when creating an algorithm. And this is not exclusively done in computer programming. This is done for anyone who's managing a project, who has a lot of things going on at once and needs to really visualize for themselves how all of these moving pieces are going to work together. So simple diagrams can be constructed that show every single step of the algorithm. And that's what a flowchart is. Typically, we are going to use rectangles, diamonds, arrows, and sometimes a few other shapes to show the general flow of a process, how one thing flows into another, one step flows into another. And that's where we get the name flowcharts. You see flowcharts most for modeling out an algorithm. All right, so we mentioned that there are some common shapes that you're going to see in a flowchart. So let's talk a little bit about what those are. First off, we have our flow line, or our arrowhead. It just looks like an arrow to us. And this shows how the program flows. It shows from one step, where does the logic of our program go? Where does the algorithm go next? We have the terminal, which is this oval shape here. This is going to show the beginning and the end of the program. The computer needs to know, where do I start following the instructions and when do I stop following those instructions? And so that's what that oval shape is going to indicate in a flowchart. Then we have our basic rectangle right over here, and that indicates a process. So when we talk about something being processed, like processed food of some sort, we're talking about something that changes the original state. And so in computer programming, we're looking at something that changes, let's say, the value of a variable, changes the location of data, changes the form of the data. So when our data is processed, it is acted upon, and something changes with it, that's going to be shown with a rectangle. All right, and then we have the diamond shape, and that is going to show when there is a condition, which way the logic will flow in the program based on what the result of the condition is. For example, if you're talking about a while loop, that I want to keep repeating a particular action while something is true, maybe coming out of this diamond, I would have an arrow going back up to the previous process, because as long as that condition evaluates to true, I want to keep going back and continuing that process. Now, on the other hand, maybe once that condition evaluates to false, then it's time to move on to the next thing. And so then maybe I would have an arrow here. So we could maybe have two different flow lines coming out of this decision block, because we need to show what happens if the condition evaluates to true and what happens if the condition evaluates to false. And last but not least, we've got input or output, and that's going to be shown by this parallelogram shape. And we've talked about input before. You used input where you would use the ask and answer set, where you'd ask a question and then you would use the answer for something. That was user input. We talked about how when you are creating a Scratch program and you want the user to interact, maybe they can press certain arrow keys to cause things to happen in your program. And again, that's user input. So whenever we need input from our user in order to have something to process or to make a decision about, then we use that parallelogram shape. Okay, so here's an example. We've got our steps. Hopefully these look familiar. These are our 4 steps for getting dressed. And we've already talked about how some of these steps are very dependent on sequence. And then some of the steps, the sequence actually doesn't matter. We just need to decide which we want to do first. So let's kind of evaluate here. Let's see what types of steps. So if we're trying to make a flowchart, we know that we have the terminal symbols for start and end. And of course I see start and end right on the screen right here. So I am going to draw a couple of ovals to show that those are our terminals, the start and end, where the computer will start and then stop following the sequence of instructions. We know that we could potentially make a decision. We could show a diamond. However, in sequencing, there is no decision to be made. We will not have anything evaluate to true or false because sequencing just means that we are doing one thing right after another. So we won't have any diamonds. I don't see any user input that is required for this. However, I do see that the state of the pants, the shoes, and the shirt needs to change. The pants are currently off and they need to be on. The shoes are off, the shirt is off, and those need to be on. So that's something that state has to change. And so that's a process. And if you recall, process is shown by a rectangle. So I'm going to go through and put rectangles around the various processes. And now what's left is to draw our flow lines or our arrows to show how one step leads into the next. All right, so on our slide in our algorithm, we decided that it is probably the best idea to put on pants first. So we'll go ahead and start, and we'll indicate that we have an arrow here. Then we said from pants, we're actually going to go and put the left shoe on. From the left shoe, we are going to go to the right, step number 3, and step number 4, we'll put on our shirt. And once the shirt is on, we are going to consider ourselves dressed, and we will tell the computer that it can stop following the instructions. So this may not be the most beautiful flowchart ever, but it absolutely, if you're brainstorming and you know, okay, I've got these things that have to happen, I'm not sure what order I want, you can sort of use this type of charting, this sort of visualization to, first of all, make sure you understand the nature of each step, and then to understand how one step leads to another and which sequence is the best for your algorithm. And after this video, you'll get a chance to try out a flowchart like this on your own. So remember, sequencing is an algorithmic logic structure where tasks are completed one by one in the exact order that they are written. It's the most simple and common type of pattern that you are going to see. And in the next lesson, you'll get a chance to see what sequencing looks like in Scratch. And flowcharts, remember, those are diagrams where we can draw out a process or an algorithm. We can try and visualize before we start putting blocks together or writing code exactly how our algorithm is going to fit together.